Hi, I am Miss Janice. This video is about first-order differential equations, where we will be focusing on the application which involve linear first-order differential equation. Before we start, let's recall what we have learned so far. We learned about order and degree of a differential equation. We know that solving differential equation means to find the original solution, y in terms of x. We came across type 1 differential equation, type 2 differential equation, where it is called the separable variable differential equation. Then we learn about the applications which involve type 2 differential equation, natural growth and decay, and Newton's law of cooling. We have also learned how to solve linear first-order differential equation, which is denoted as LFODE. First, if the first-order differential equation can be written in the form of dy over dx plus pxy equals to qx, this means it is a linear first-order DE. To solve it, first step, we find rho, which is equals to e to the power of integrate px dx. In the second step, we multiply the whole differential equation with rho and integrate with respect to x both sides. So look at this linear first order DE. After we have found rho, for this DE, we multiply rho same go to the right hand side, multiply rho. Then we integrate with respect to x both sides. For left hand side, it will always give us rho y equivalent to the right hand side. We just need to integrate the right hand side in order to solve for the differential equation. These are the steps to be followed in order to solve LFODE. Now, let's go to the application question. Example 5, number 4. A 120-gallon tank initially contains 90 pounds of salt dissolved in 90 gallons of water. Here there is a chemical tank. If it is full tank, it can carry up to 120 gallons of liquid. Initially, this tank has 90 pounds of salt and 90 gallons of water. Brine containing 2 pounds per gallon of salt flows into the tank at the rate of 4 gallons per minute. This is the salt, 2 pounds per gallon. So it is actually the concentration of the salt. Just like making a glass of Ribena. If you want the Ribena to be very concentrated, you put more Ribena, right, into say 200 cm cube of water. If you want it to be more concentrated, you put more Ribena, right? So this is actually the concentration of the salt. It is 2 pounds for each gallon. So concentration of the inlet is 2 pounds per gallon. Flows into the tank at the rate of 4 gallons for every minute. Flow inside with 4 gallons per minute. So this is actually the flow rate of the inlet, 4 gallons per minute. And the well-stirred mixture flows out of the tank at the rate of 3 gallons per minute. So there is an outlet here. So the flow rate is 3 gallons per minute. Flow rate of the outlet is 3 gallons per minute. So in 4 gallons per minute, out 3 gallons per minute. Meaning that for every minute, this tank will have additional of 1 gallon of liquid coming in. So eventually it will become full, right? 4 in, 3 out. Overall, it is 4 minus 3, 1 gallon in. How much salt does the tank contain when it is full? In the tank, there is salt, 90 pounds per 90 gallon. Then for the inlet, also salt is keep on coming in. At the outlet, salt is going out. So the amount of salt in the tank is changing according to time. We denote it as a function S in terms of T. ST. Amount of salt is the variable. Here the question asks us to find the amount of salt, which is a question mark, when the volume of the liquid is full, which is 120 gallons. So how do we solve this? First of all, we know that the variable is S, amount of salt, S in the tank. We need to form a differential equation based on this chemical tank situation. ds over dt. The rate of change of amount of salt in the tank, ds over dt, is actually equals to the rate of change of the amount of salt at the inlet minus the rate of change of the amount of salt at the outlet. We start the formation of the differential equation with this equation. Now let's talk about the unit, ds over dt, amount of salt versus time, which is pound per minute in this question. So this equation must be in the units of pound per minute. For S prime in, let's look at the inlet. We have C and F. If we take C times F, for the unit, it is pound per gallon times gallon per minute, which will give us pound per minute, right? So S prime in will be C in times F in minus, for S prime out will be C out times F out. Substitute. ds over dt will be equals to 2 times 4 minus, what happened to the concentration at the outlet? The concentration at the outlet, C out, will be equivalent to the amount of salt coming out, which is actually a variable, right? It is changing based on the time, over the volume in the tank, over the volume of the liquid in the tank. So we need to find the volume function. We know that dV over dt, the rate of change of the volume in the tank, will be equivalent to V prime in minus V prime out. Look at dV over dt. This is volume versus time, which means gallon over minute. So for V prime in, at the inlet, we have a unit flow rate, which is in gallon per minute. So V prime in is same as F in minus V prime out, which is F out. So substitute 4 minus 3. dV over dt is equivalent to 4 minus 3, which is 1. Let's solve for V function. It will be integrate 1 with respect to time. Volume is T plus C. We have initial condition. Volume is 90 gallon and the time is 0 because that is the starting point. So substitute 90 equals to 0 plus C. C is 90. From here, we have found our volume function, which is T plus 90. So for concentration at the outlet, it will then be S over T plus 90. So let's substitute S over T plus 90 times the flow rate, which is 3. So writing this in proper form, which is minus 3 over T plus 90 dot S. We have formed the differential equation for this situation. So now we need to solve this differential equation in order to answer for the question. So in order to solve this differential equation, first we check what is the highest derivative. First derivative is the highest derivative. This is first order dE. Then we need to rearrange, see which type is the dE. So first I will bring the S term to the left, plus 3 over T plus 90 dot S equals to 8. When I let S be Y and T be X, you will notice this differential equation is actually a linear first order differential equation, LFODE. Plus 3 over X plus 90 dot Y equals to 8, which it is written in the form of dy over dx plus pxy equals to qx. Px is 3 by x plus 90, right? So this dE is LFODE. Now we know that this differential equation is LFODE, so we move on to solve it by using the right steps. Continue in the next page. Write down the dE first. ds over dt plus 3 over t plus 9d dot s equals to 8. This is LFODE. To solve it, we follow step 1, which is to find rho, which is equals to e to the power of integrate 3 over t plus 9d dt. Solving this, we will get t plus 9d power of 3. Continue with second steps. Multiply rho and integrate with respect to t, because it is in terms of t here instead of x. Integrate with respect to t, both sides. From the LFODE, let's multiply with rho first. Left hand side settle, then we integrate with respect to t for the left hand side, equals to do the same for the right hand side. Integrate with respect to t. In step 3, left hand side will always give us rho y. Rho is this, t plus 9d power of 3 dot y. Y here is actually s, equals to integrate the right hand side will give us 2t plus 9d power of 4 plus c. So we have found the s function. S is actually 2t plus 9d power of 1 plus c, t plus 9d power of negative 3. We need to find the constancy based on the initial condition. When T0, the amount of salt S is 90. Check that, see. Initial condition, 90 pounds of salt, 90 gallons of water. Substitute it, 90 equals to 2 times 90 plus C, 90 power of negative 3. Solving C, we get negative 6561,000. Therefore, the S function will be 2 times t plus 90 minus 6561,000 times t plus 90 power of negative 3. With the S function found, the amount of salt in the chemical tank is S. We are ready to answer the question to find S when V is 120. We know that S function is in terms of t. Therefore, with V equals to 120, we can find the time where the tank is full. Substitute V 120 to get the t. V equals to t plus 90. So when V 120, t will be, sub in, we get 30. So here, when t 30, we can get the amount of salt in the chemical tank. 2 times 120 minus 6561,000 times 120 power of negative 3. Using calculator, S is 202 pounds. Here we have learned how to solve a mixing problem in chemical tank which involves the linear first order dE, LFODE. For chemical tank question, based on the sketching, we need to form a differential equation involving the rate of change of the amount of salt in the tank, ds over dt, which is s prime in minus s prime out. For s prime, ds over dt, it must be in the units of pound per minute in this case. So look at the inlet, we have C and F. By using C times F, we can form S prime, which will give us a value in the units of pound per minute. While for S prime out, look at the outlet, we only have F. We don't have the concentration. So we need to find the concentration function, which is S over V. Concentration is the amount of salt over the volume of the liquid in the tank, S over V. For the volume function, the volume in this tank is changing. So we need to form volume function. dV over dt equals to V prime in minus V prime out. dV over dt, the unit is in gallon per minute in this case. Look at the inlet. We have a value in gallon per minute, which is flow rate, F in. So V prime in minus V prime out will be equivalent to F in minus F out. That is 4 minus 3. dV over dt is 1. Solving this differential equation, we got the volume function, V equals to T plus C. Substitute the initial condition, we get a complete volume function, V equals to T plus 9E. Substitute V into the concentration at the outlet, C out equals to S over T plus 9E. With C out found, then we can substitute it into the differential equation and have a complete differential equation. The next step is to check which type of differential equation is this. Here it is LFODE. So we follow step 1, 2, 3 to solve for the S. With the initial condition substituted, we get the particular solution for the S amount of salt in the tank. Then ready to answer the question to get S when the tank is full. That is all for today's lesson. Thank you for watching.